Good morning, everybody. In this video, we are going to work through some sample stoichiometry problems, okay, just so you have some more examples to help you get through homework and stuff. So make sure you get on Google Classroom, okay? I uploaded this document, so if you can, print it out and work through the problems with me, okay? So that way, you're participating and you'll learn this a lot easier if you actually work through the problems with me instead of just, watching the videos and doing nothing. Okay. Um, so let's get going. We have our first problem. Consider the reaction. We have potassium chlorate is decomposing, right? That's a decomp reaction, only one reactant. It's decomposing to potassium chloride and oxygen. Okay. So we can see it's balanced, right? We see there's already coefficients there. This one's already balanced for you. Okay, so all we need to do is just the stoichiometry part. Okay, so the first question says, how many grams of oxygen will be formed from 1.65 moles of potassium chlorate? Okay, so what we need to do is we're looking for information about grams of oxygen, right? So if we're referencing our flow chart, okay, we want to find information or our unknown substance is grams of oxygen. Okay, so this is where we're trying to get to on our flow chart. And where are we starting? Well, formed from 1.65 moles of potassium chlorate. Okay, so our known substance or our substance that we're given information about is potassium chlorate. And we're starting off with moles of potassium chlorate. Okay, so we're starting off at this point in our flow chart. I think in yesterday's videos, we were always either at particles or mass. It's possible to start out at moles of your first substance. Okay, and that's actually kind of nice, right? Because now this is a problem that can be solved in 1-2 steps. Okay, so in our first step, we're going to go from moles of potassium chlorate to moles of our unknown, which we said was oxygen. Okay, so step 1, we're going to go moles to moles, okay, using the mole ratio. That's the new concept here. Okay, and then after we do that, we're going to go from moles of oxygen to grams of oxygen using the molar mass of oxygen. Okay, so that's something that you already know how to do. All right, so let's get going. We said we're starting out here with moles of potassium chlorate. Okay, so we've got 1.65 moles of potassium chlorate. Okay, and now to get to moles of oxygen, we need to look at that mole ratio from our balanced equation. Okay, remember, those values come from the coefficients, right? Because what this equation is saying is for every 2 potassium chlorates that react, we get 3 oxygens out of it, or 3 oxygen gas molecules out, right? For every 2 moles of this that we put in, 2 moles, I'm going to put moles of potassium chloride on the bottom here, right? Because I want that to cancel out. Okay, and I'm trying to get to moles of oxygen, so that needs to go on the top. We make 3 moles of oxygen. Okay, so that's the first step of our T-chart. That's just, this is the mole ratio. Okay, and where did this come from? Again, it came from the coefficients in my balanced equation. Okay, every 2 moles of potassium chlorate that we put in, we get 3 moles of oxygen out. Okay, so at this step, we've canceled out moles of potassium chlorate. Okay, now we're at moles of oxygen, and we know we want to get rid of moles of oxygen because the question's asking for grams or mass of oxygen. Okay, so the way we're going to do that is we need to use the molar mass of oxygen. Okay. 1 mole of, notice it's O2, you guys, right? Because it's the substance in the equation. Okay, so it needs to be O2 because oxygen is diatomic. Okay, take a second, pause the video, see if you can calculate the molar mass of oxygen gas. Okay, we should come up with 32 grams of oxygen per mole of oxygen. Okay, and again, you'll notice that I have labeled all of my substances, right? Potassium chlorate, oxygen, oxygen. Okay, so if we look at what's going on with our units, everything is canceled. We're left with grams of oxygen, which is good. That's what we're looking for. Okay, now we just need to take out our calculators, crunch these numbers. So we've got 1.65 times 3 divided by 2 times 32. Okay, and when we do that, we get this as our answer, and you'll notice it's already at 3 sig figs, so we don't need to worry about it. Okay, again, the coefficients, those are exact values. Okay, those have infinite sig figs, so they're not really going to count towards our sig figs. Okay, so our final answer is 79.2 grams of oxygen. Okay, and just like that, we're done with that one. Let's move on and do the next question. Okay, so this question says, how many molecules of potassium chlorate are needed to produce 3.5 grams of potassium chloride? All right, all we need to do, figure out on our flowchart, where are we starting, where are we stopping, okay? And then just take it one step at a time. That's how you got to solve these, is just piece by piece, okay? So how many molecules of potassium chlorate? Well, molecules of our unknown, right? How many? This is where we're going to end up on our flowchart. We're asked to find molecules of potassium chlorate. And we're starting out, we have information about grams of potassium chloride. Okay, so in this question, we're going all the way across the flowchart. Okay, so our first step, we're going to need to go from grams of potassium chloride to moles of potassium chloride. Okay, then we'll do moles of potassium chloride to moles of potassium chlorate. And then from there, we'll go moles of potassium chlorate, molecules of potassium chlorate. Okay, so we're going bottom left to top right on our flowchart. Okay, we'll take it one step at a time, start with what we're given. Oops. We're starting with potassium chloride. Okay, we have grams. We want to cancel out grams and get to moles. We need the molar mass of potassium chloride. So take a second, pause the video, see if you can figure out what that is. Okay, you should find that 1 mole of potassium chloride weighs 74.55 grams. Okay. Again, for our molar mass, we needed to have grams on the bottom so that grams of potassium chloride cancels out. And now our unit that we're at is moles of potassium chloride. Okay, so all that was a molar mass. You already know how to do that. Now for the new step, okay, now we need to go moles of potassium chloride to moles of potassium chlorate. Well, where do we need to look? Look at it, it's on your flowchart. You need to look for those numbers from your balanced equation. Okay, so here's our balanced equation, right? I'm going to put moles of potassium chloride on the bottom, 2 moles of potassium chloride comes from 2 moles of potassium chlorate. Okay, so when we use this mole ratio, again, we're doing that to get rid of moles of potassium chloride and move on to moles of potassium chlorate. Okay, so now we're here at this step. Okay, and then the last step from our flowchart, we're just going moles of potassium chlorate to molecules. Again, we do that using Avogadro's number, right? In 1 mole of potassium chlorate, I put 1 mole on the bottom so that that unit cancels out. In 1 mole of potassium chlorate, we know that there are Avogadro's number of molecules of potassium chlorate. Okay? I like to draw my horizontal line at the end. It makes everything feel neater, but if you draw it in each step, that's fine. Whatever floats your boat. Okay? So verify all of our units have canceled out. Okay? Looks good. Plug it in your calculator. Again, be careful, watch out for that scientific notation input. All right, so we've got 3.5 divided by 74.55 times 2 divided by 2. Okay, if it makes you more comfortable, you can put that in your calculator. Okay, but we're multiplying and then dividing right away by 2. So really, this is not mathematically going to affect our final answer. So you can put that in there if you want. You don't have to if you have the math skills to recognize that that will cancel. Okay, and then we're going to multiply that by 6.022e 23. Okay, and we get, holy guacamole, okay? This makes sense though, right? We should have a lot of molecules, right? Anytime you're solving for particles, molecules, atoms, any of that stuff, you're going to want some scientific notation there because it takes a lot of molecules, again, to measure on the scale of grams, okay? So we want to round this answer to 3 sig figs because we started with 3, right? That trailing 0 counts because we have a decimal there. Okay, so we want to keep. We're going to round this to the 10th place, and that 7 is going to bump our 2 up to a 3, so we get 2.83 times 10 to the 22nd molecules of potassium chlorate. Okay? Let's look at the next one, and this is the last one for this equation. Okay? How many moles of potassium chloride will be formed from 2.73 moles of potassium chlorate? Okay, use your flow chart. Figure out where am I starting, where do I want to end up? Okay, how many moles of potassium chloride? We're asked to find moles of something. They are unknown substance. We're looking for moles. Will be formed from 2.73 moles of potassium chlorate. Okay, so we're starting with moles of potassium chlorate. That's what we're given, right? Our known substance that we have info about, potassium chlorate. We know moles. Moles of potassium chlorate, moles of potassium chloride. Look at that. This is a one-step conversion using that mole ratio. Okay, so we're starting out with moles of one thing. Moles of potassium chlorate. Okay, remember, look at your balanced equation to find that mole ratio. Okay, here's our balanced equation. We see that 2 moles of potassium chlorate, so I'm going to put that on the bottom of this conversion, gives us 2 moles of potassium chloride. That's it. That's it for this problem. It's just a one-step mole ratio conversion. Okay? And look at this. You'll even notice we multiply by 2, we divide by 2. Okay, if you want to input this in your calculator, you can, but you might notice those 2's are going to cancel each other out as well. So we end up with 2.73 moles of potassium chloride. Okay, and that's really because this 2-to-2 mole ratio obviously simplifies to a 1-to-1. You get the same amount in moles of potassium chloride out as you put in of potassium chlorate. Okay? So hopefully you worked through those with me. C was the easiest one, A was medium, B was the hardest one, right? Because in B we went bottom left to top right on our flow chart. Okay, so B really brought in all the different types of conversion factors. We had a molar mass, a mole ratio, and Avogadro's number in that one. Okay, so hopefully this was helpful. I will upload more videos of myself working through the entire rest of this packet, okay? Tons of practice for you.